So you've been told a large morgue is to be made in form of a rectangular box-like shape. So you've been told a large morgue is to be made in form of a rectangular box-like shape. A large morgue is to be made in form of a rectangular box-like shape with canvas covering on the top, back, and sides. Are you getting that? The canvas is covering the top, back, and what? And sides. Are we together? Determine the minimum surface area of the canvas necessary if the volume of the morgue is to be 250 centimeters cubed. So you've been told the volume is to be 250 centimeters cubed. So a rectangular box-like shape, we have length, width, and height. Are we together? So it means the volume is length times width times height, length times height times width, which is 250. Are we together? So from here, when you have length times width times height to be 250, you can make one of them the subject of the formula so that you have only two variables. You have only two variables. So if you make, for instance, if you make length the subject of the formula, you divide both sides by HW, isn't it? So you get length will be the same as 250 over H over HW, height and width. Are we together? Because you've been told to determine the minimum surface area. When you hear the word minimum value, then that is a minimum value is a nature of a stationary point, meaning we use the concept of the stationary points to determine that minimum surface area. Are we together? So what is this surface area? So we found L is just 250 over WH. Or you can use W to be the subject or H to be the subject, whichever you choose, okay? Are we together there? Yes. What do you want? You want the surface area. So how do you get the surface area of an object? You were told with canvas covering on the top, back, and side. Are we together? You know, a morgue is a building. Are you getting that? It is a building. So it is the top which is covered. So it is like they are telling you maybe, even if you say iron sheet, with iron sheet covering the top, back, and sides. Are we together? So it means the floor is not included. Are you getting the argument there? The floor which is the bottom. Remember, back is the back. And the front and the other ones, those ones become sides. Are you getting that? And the top is there, like the roofing. Are we together? But now they have not talked about the bottom, that is the floor. Are you getting that? So the floor is not part of the surface area you want to determine. Are we together? The floor is not included. Are we together there? Because you've been told the canvas is covering on the top, back, and sides. Top is not included. Are we together? What else is not included? Because if you listen to that statement, the front is also not included. You see that? Because the front of the morgue may be, the whole of it may be open, or it may be covered by something else, isn't it? Are you getting the statement? You've been told the top, back, and side. So the front of the morgue, the whole of it may be the open, or the whole of it may be having big doors and covered with something else, isn't it? Are we together there? Have you gotten the point right? So we are not interested in this front cover, and we are not interested with this floor. Are we together? So what is the total surface area of the back which is left? Start with the back. The back is length times height, isn't it? So you found the surface area of the back is length times height. Are we together? If you write them, what is the surface area of the back? So it is this length times the height. You get the back is length times height. Then, what else have you been told is covered? The top, isn't it? What is the top? See, the top is length times width. Is that okay? The top is length times width. What else have you been told is covered? The sides, isn't it? You've been told the sides are covered. And how many sides do we have? See, only two sides. We have the back, two sides, and front, isn't it? Are we together? So the two sides is what? Width times height, and there are two of them, so 2 width times height. Have you gotten the statement right? So this morgue, it is the top, back, and sides which are covered with the canvas. The floor and the front is not covered with that. Are we together? Are we together? So what is the total surface area? So it's the total surface area which we've denoted by L. We did not use that. The total surface area which we've denoted by S is going to be what? Back plus the surface area of the top plus the surface area of the sides, isn't it? So you get the total surface area to be LH plus LW plus 2WH, isn't it? But now, you see this surface area is a function of three variables. It is a function of L, H, and W. So that is where the volume comes in. The volume now comes in to help us eliminate one variable. So we only have S as a function of two variables only. So that we are able to determine the stationary points and their nature. And we are not interested in their nature, we are only interested in that stationary point. And the stationary point is what will give us the length and height and width. So when they say it is the minimum value, the minimum surface area, when they talk about the minimum surface area, then they're saying that point is the least value. Are you seeing that? Are you seeing? And when they say the maximum surface area, it means at that point is the utmost, isn't it? Are we together? The maximum area. So it means we are interested in looking for that stationary point alone. We are not interested in its nature. Because the nature means that it is at that point where it will be the minimum as per the description, or it is at that point when it will be the maximum what's required. Are we together? So maximum means at that given length, you cannot go beyond that, isn't it? And the minimum means at that given length, it is from there and above. So it is at that point we are not interested. We are interested in. So we are not interested in the nature of the stationary point. We are not going to look for the discriminant. Are you getting that? We are only looking for the stationary points. Is that clear? So here we now have what is the surface area. Let's get rid of that L, because L you said is 250 over WH. Anywhere you see L, you put 250 over WH, so that is L times H, then plus L, which is 250 over WH, then it is L times W, then plus 2WH. So what do we get? What do we get? We get the surface area to be, you can see H goes with H, 250 over W, isn't it? 250 over W is the same as 250W raised to power 1, isn't it? Then you move to the next one, W goes with W, 250 over H is plus 250H raised to negative 1, isn't it? Then it is plus 2WH. So you see, you found S to be a function of W and H. Are we together? So what did we say? At the stationary point, the derivative is 0. So because S is a function of W and H, we want to differentiate S partially with respect to W and S partially with respect to H. So if S is a function of WH, then it means F of WH is equals to what? 250 W raised to negative 1 plus 250 H raised to negative 1 plus 2WH. Are we together? So the first thing we want to do, we want to partition F partially with respect to W, isn't it? So if we differentiate F partially with respect to W, it means only W is a variable, isn't it? What do you get? If you differentiate this partially with respect to W, you see negative 1 times 250. You get negative 250, then you reduce the power by 1. Negative 1 minus 1 is negative 2, isn't it? Are we together? You go here, there is no W here, we are doing it partially with respect to W, meaning the whole of this term is constant, isn't it? So if you differentiate it partially with respect to W, you get 0, isn't it? You move to this one, if you differentiate it partially with respect to W, it means 2H is a constant, isn't it? Then you differentiate W, you get 1. So it is 2H times 1, which is just 2. Are we together? Go to the next one. We now want to differentiate F partially with respect to H. Is that okay? So if you differentiate it partially with respect to h, it means only h is a variable, isn't it? Anything else is a constant. So if you differentiate this partially with respect to h, it is the f of x. It is the f we are differentiating, isn't it? This partially with respect to h, you get 0. If you differentiate this partially with respect to h, you get negative 250. Then you reduce the power of h by 1. Negative 1 minus 1 is negative 2, isn't it? If you differentiate this partially with respect to h, it means plus 2w is a constant, isn't it? You differentiate h, you get 1. So you remain with the plus 2w. Are we together? Then you now come at the stationary point. At the stationary point, the derivative of the function is 0, isn't it? So it means either partial derivative with respect to w is 0 or partial derivative with respect to h is 0. Are we together? So can you now call your f partially with respect to w is negative 250 w raised to negative 2 plus 2h to be equals to 0. Then this function partially with respect to h, which is negative 250 h raised to negative 2 plus 2w is equals to 0. Are we together? Is that okay? See, we now solve the two equations. Now to solve the two equations, what do we do? Start with the first one. The first equation is that. The second one is that. So the first one, you can take this negative 250 and w negative to the other side, isn't it? So you get 2h is equals to 250 w raised to negative 2, isn't it? Are we together? So you can divide both sides by 2. You get h is 125 w raised to negative 2. That is the same as 125 over w squared. Are we together? H is 125 over w squared. So from here, again, in this first equation, we now see we have h is equals to 125 over w squared. If you can as well make w squared the subject to be 125 over h. That is the first equation. Go to the second one. The second one, you have 2w to be equals to, you take this negative the other side, you get 250, h raised to negative 2, it means over h squared, isn't it? Just like we've done with this, isn't it? Are we together? You divide both sides by 2, you get w to be 125 over h squared. Now look at these two equations. All of them are for w. Meaning w is 125 over h squared, here is w squared is 125 over h. So what does that imply? It means where there is w, we put 125 over h squared. We use substitution, isn't it? Are we together? Where there is w, we put 125 over h squared. That is why I was making w the subject of both cases. Or I would have made h the subject of both cases, whichever, isn't it? If I would have used h to be this, meaning I would have made h squared the subject of that. Isn't it? Are we together? Good. So what do you get? And remember that formula of surface area? What do we have? We have here w squared, but w is what? 125 over h squared. W squared, this we are substituting, isn't it? W squared is equals to 125 over h. So we've substituted the value of w where there is w. Here, we put that value of w. Substitution, isn't it? So you get 125, the square is for everything. 125 squared over h squared, 2 times 2. See, 2 times 2 is 4. To be equals to 125. Are we together? 125 over, you can cross multiply, isn't it? So if you cross multiply, you get 125 squared h is equals to 125 h raised to power 4. So you can see you can divide both sides of the equation by 125h, isn't it? By 125, h is a common factor. So 125 goes with 125 here, h goes with h, 125 into 125 squared, so you remain with 125. Isn't it? Here 125 goes to 125. H raised to the power 4 divided by h, you remain with h cubed. Isn't it? So for you to get h, you look for the cube root on both sides of the equation. Meaning, you raise both sides of the equation to the power third to remain with h. 3 times that, you remain with h to be the cube root of 125. What is the cube root of 125? 5. So you found h to be 5. After getting h to be 5, so you can use either of the two equations to get w. W is 125 over h squared. So what is w? 125 over 5 squared. You get w to be 5. 125 over 5, isn't it? So we found w and h to be 5, 5. Is that okay? We found w also to be 5. So let us go back to our original problem. What did we have? The first thing we had is we need to get L. Remember our L was 250 over W over WH, meaning it is 250 over 5 by 5. You get? So you get 10. 10. So it means the length is 10. Now after getting all the dimensions, height, width and length, we now need that minimum surface area, isn't it? So that minimum surface area, we were looking for the back which we found was L times. See the back when we drew that diagram. See it was L times H. It was the back, then the sides were 2, isn't it? The sides was width times height, and there were 2 of them. And we had the top, isn't it? We had the top, which was length times width, isn't it? So these are the surfaces which were covered. So what is the surface area here? Meaning for the surface area to be minimum, height has to be 5, width has to be 5, length has to be 10. That is when the surface area will be minimum. Is that okay? So what is the surface area? It is back plus sides plus top. Are we together? LH plus 2WH plus LW. Do the substitution. L times H, 10 times 5, 50 plus 2WH, 2 times 5 times 5, 50 plus L times width, see 50. Then you get it is 150 centimeters square. And you have solved that given problem. Meaning, this is the minimum surface area. For the surface area to be minimum, the height has to be 5, the width has to be 5, and the length has to be 10. Are we together? Good.